Assalamualaikum. Nama saya Muhammad Ijazi Muhammad Zufri, nombor metrik B06 BTT 22F513 dan bersama saya Safu Amirul Faris bin Sebuah Bahari. Nombor metrik B06 BTT 22F524. Kami ingin menerangkan pasal data communication. Basic data communication system defined as the transmission of digital information between two devices using electronic transmission system. Data will be representation either in the form of electrical signal, electromagnetic wave, or light. Example: source, voice, text, video, and picture. Second, transmission medium, cable, and fiber optic. Destination, computer, and telephone. Right. DTE, data terminal equipment. DTE refers to interface equipment used at the station between the host and modem to adapt the digital signal from the computer and terminal to a suitable form for transmission. Examples for DTE: computer, and then visual monitor, logic controller unit, and store buffer. Next, DCE, data circuit equipment. DCE means the equipment that converts digital signals to the analog signal and interface the data terminal equipment to the analog transmission medium. DCE is a modulator or modulator. It converts binary digital signal to analog signal such as FSK, PSK, and QAM, and vice versa. Like this. Yeah.
Hai, saya Safu Amirul Faris. Today saya nak explain pasal data communication model in networking. First, we got sender. The source terminal or source will generate the message that need to be transferred, and the transducer will convert that message into an electrical signal or digital signal. Second, we got transmitter. The transmitter won't directly send the data to the end node or the destination. The transmitter will identify the source, and it will transform or decode the information in such a way to produce electromagnetic signal that can be transmitted into a transmission system. Kita ada transmission. As it is directly connected to the source to end destination, it can send the transmitted data or information to the receiving end via guide by or unguided media. Data will be transferred through electromagnetic wave. We can use various waves cable such as fiber optic, radio frequency, wireless medium, and etc. Fourth, we got receiver. The receiver is a device that receives the signal and amplifies them, as well as remove the unwanted noise or the unwanted signal to dispatch or decode actual data and feed it to the destination node. Next, we got destination. The end node or user will finally receive the message through the data terminal equipment station at the other side. Those end node may be terminal, computer, or any other medium like printer or mainframe computer. To understand this very clearly, we can take example of public telephone network. Okay, next I will explain layer of data communication model. First, identify the data. Determine what data you want to send. This could be text, file, image, or any other form of information. Next, sender application layer, layer 7. Prepare the data transmission. This might involve formatting or encoding the data depending on the application's requirement. Next, we have sender presentation layer, layer 6. If necessary, perform data translation, encryption, or compression. And next, we have sender session layer, layer 5. Establish a session or connection with the receiver. This may involve authentication and negotiation of communication parameter. Next, sender transport layer, layer 4. Segment the data into smaller packet if it large. And then assign sequence number to packet for reordering and error detection. And next, and then add header with source and destination port number as well as error checking information. Okay, let's move to next layer, which is sender network layer, layer 3. Determine the best path to reach the receiver, which means routing. Then next, and then add source and destination IP address to the packet. This 2 is from layer 3. Now, next layer is sender data link layer, layer 2. If applicable, frame the packet of specific network technology being used, such as Ethernet frame. Add source and destination on MAC address. Okay. Now we go to next layer, which is sender physical layer, layer 1. Convert the digital into electrical or optical signal for transmission over physical medium. Like for example, cable, wireless signal. Okay, now we go to receiver layer. First layer is receiver physical layer, which is layer 1. Receive and convert the signal back into digital data. Second layer, receiver data link layer. Extract the frame, check for error, and ensure data integrity. Third layer, receiver network layer. Use the destination IP address to route the packet to the appropriate destination. Fourth layer is receiver transport layer. Reassemble the data packet in the correct order using sequence number. Check for any missing or corrupted packet. Next layer, receiver session layer, layer 5. Close the session if necessary and clean up resource. Next layer is receiver presentation layer, layer 6. If necessary, perform data decryption, compression, or translation. The last layer is receiver application layer. Deliver the data to the receiving application for the process. That's all for me. Thank you.